Hi everyone. Today we're going to discuss a Form 4 MS questions on solution of triangle. Now this question is considered a hot question because we need to know about the triangle. Now let's look at the question. The diagram shows a tent VPQR in the shape of pyramid with triangle PQR as the horizontal base. So this is the base. Okay, and V is the vertex. So if V is the vertex, so let's get this so that you can see the 3D shape of this diagram. Okay, now, so given that VQ equals to VR, so VQ equals to VR, which is 2.5, and then PQ equals to PR, so this two is equal in length, 3 meters. So over here we have two isosceles triangle. One is PQR, okay, another one is VQR, so VQR, whereby it's 2.5 and 2.5 here. Then with that, if this is isosceles triangle, we must know that there will be one axis of symmetry, okay, that divide this triangle into two equal parts at 90 degrees. And let's just call this one M. And on the other hand, for our triangle PQR, the base, since it's also the isosceles triangle, 3 meter, 3 meter, we also can draw the axis of symmetry, okay, and they will meet at M. So over here, we have M, and from the vertex of V, we will have this one. Now, why do I need to draw this? Because you look at the next information. It says the angle between the inclined plane VQR and the base is 55. How do we identify the angle between two planes? Now, watch this. When we have two planes, let's just write the two planes side by side. We have VQR and also PQR. First of all, identify the common intersecting line, which is QR. Okay, in this case, our QR, there is an M there. Why? Why do we need to create the M there? Because we left with the point of V from the plane VQR. So from V, which point should we connect to so that it make 90 degrees to QR? It's M. So the angle formed will be on M, okay? And then from the plane VQR, it will be V, okay? It make 90 degrees to QR at M. And at the same time, the P, the second point from the second at the base, the P will make 90 degrees to QR at M also. Therefore, the angle formed will be in the combination of these two lines, formed by these two lines, which is V and P. So V and P will be that angle that we should label, that is 55. Okay, now let's move on to part A. Part A says find the length of QR if the area of the base is 3.3. So the area here is given 3.3. So we have side 1, side 2, and then we need to find side 3. So in this case, we have to use the Heron's formula. Because to find the area of triangle, we've got two formulas. One is half AB sine C. This is to find the area of triangle. Another one will be Heron's formula, S times S minus A, S minus B, and then times S minus C. Don't forget to square root it. Okay, so between these two, there is no angle given, therefore we need to use the Heron's formula. So before that, we have to find out what is our semi-perimeter. So let me label the QR, okay, let's QR to be A. So our semi-parameter will be 3 plus 3 plus A, and then divided by 2. So we will have 6 plus A divided by 2. So this one I would like to write in 2 terms. 3 plus half A. Now with that, let's put into our formula. That is A equals to 3.3. So S 3 plus half A times S minus A, 3 plus half A minus A, and then S minus B, 3 plus half A minus 3 in this case, and then C is also 3 plus half A minus 3, equivalent to 3.3. There should be a square root there, so I bring the square root across, so I square the 3.3. So over here, we can just simplify the expression in the bracket first. Now 3 plus A minus A, 3 plus half A minus A, we will have 3 minus half A. This one, the 3 cancel off each other. We're left with half A times with half A. That will be 10.89. So this one, 3 plus half A, 3 minus half A, is actually difference between two perfect squares. So we can just take 3 squared minus square of A over 2. That will be A squared over 4. Okay, so for those who are not sure what is this, it is actually this one. If you see A plus B, A minus B, that will be difference between two perfect square. We're actually using this to apply in here. Okay, let's continue. So A, half A times half A, we will have A squared over 4, which equivalent to 10.89. Now, in order to make things look much simpler, I will just let X be A squared over 4. So with that, we will have 9 minus AX, minus X times X equals to 10.89. So when up to here, you see square, when we expand, you will see the square. So we will have 9x minus x squared equals to 10.89 quadratic equation. So we got to solve it, but we need to rewrite it in ax squared plus bx plus c. Put them all together, yeah, equals to 0. Then only we can solve this. Now this is not a whole number, so we have to use the formula. So x equals to minus b. Our b is negative 9 plus minus square root of b squared, negative 9 squared minus 4ac. 1c is 10.89 divided by 2a, which is this. Okay, what am I doing here is actually using the formula. For those who are not sure what am I doing, I'm using this formula. X equals to minus b plus minus square root of b squared minus 4ac over 2a. When to use this? When we know it's impossible for me to find the factors for 10.89 using the two bracket way. So I use the formula right away. So use calculator and calculate. We will get the answer 7.56 or 1.44 here. And don't forget, x will represent a squared over 4. Our final objective is to find a. So for that, we got a equals to two values. One is 5.5, another one is 2.4. Now, so for this two, which one should we choose? Is it 5.5 or 2.4? Now, this is what I said, the k-but part. Remember, we got the QR, okay, which is A. We have VQR, which is 2.5 and 2.5 just now. And also we have another one that is also have QR as one of the side, which is PQR. 3 here. So which one should we take? Is it 5.5 or 2.4? So over here, you need to know that in order for a triangle to exist, the three sides, side 1, side 2, and side 3, what are their relationship? You just take any two sides, you add together, it must be greater than the third side. So let's check. 2.5 plus 2.5 is 5. So 5 is less than 5.5. You see, 2.5 plus 2.5 is actually 5. So we need to have the third side, which must be greater. So 5.5 is actually less. Okay, the sum of these two sides is actually less than the 5.5. So we cannot accept 5.5. So we got to reject this. See, we just use this triangle to test. Now, if you take the 2.4, you see 5 definitely is greater than 2.4. So we can accept this one. But for the triangle PQR, both also can be accepted. So the one that determines which one to be acceptable, that will be from the triangle VQR. So therefore, QR will equals to 2.4 meter only. Okay? Because of this, S1 plus S2 must be greater than the third side. You can try to use your compasses to construct with the 5.5. You construct the 5.5 first, and you try to construct the 2.5 and 2.5. See if you can find the point V. Okay, you can try that. Okay, but the answer is 5.5. We got to reject. So we have found the answer for part A, which is 2.4 meter. Now let's move on to part B. Okay, so this is 2.4. Yeah. Now part B, we need to find the length of PV if the angle of PV and the base is 50 degrees. So again, we have to identify, so the PV and the base, which is PQR, we need to identify the angle between this line and the plane. So what we got to find a common point. So over here, P is the common point. Therefore, the angle formed must be on P. So from this line, we have to think how this V will name the angle VP, and then the other representative from the base PQR will be the point M. We join to the center. Okay, so VPM is the angle. So since VPM is the angle, let me take that triangle out. VPM, this is VPM. Okay, so this one is 50 degree. We've got 50 degree here. And then the VP, the PV is the one that we need to find. Yeah? Okay, I don't know what is this. And then we have, just now we have the angle 55. Can you see that? It is angle VMP. So VMP was given 55. So we can use sine rule here because the opposite angle match with the opposite sides. The angle match with the opposite side. So in this case, I need to find VM. How do I find VM? You look at this triangle here, VM. Let me just take that triangle out. Okay, B, the M is right in the middle here. QR we just found is 2.4. And the axis of symmetry will divide the QR into two equal parts. So over here we have 1.2. And VR is given 2.5. So with that, we can find VM. So VM will equals to 2.5 squared minus 1.2 squared. Pythagoras theorem. So use the calculator, we get 2.193. Okay, so just put it here, 2.193. So now we apply the sine rule. The sine rule say PV is the one that we want. Okay, match with the opposite angle, 55, equivalent to the ratio of 2.193, match with the opposite angle, sine 50 degree. Okay, using calculator, take 2.193 over sine 50 times sine 55, we got 2.345 meter. That is our answer, 2.345. Okay, found it. Next, what do we want? We need to find the area of VRP. Now, the area of VRP basically is this one. VRP. Okay, so that is our VRP. So let's just get that triangle out so that our focus will be on that triangle only. VRP. Okay, this is V, R, and we know the VR, which is the same as the VQ, is 2.5, and VP, we just found VP to be 2.345 in part B, and then the PR was given also 3 meter. So we need to find this area. So how? With 3 sides, we can only apply the Heron's formula. So let's find the semi-perimeter, which is 2.5 plus 2.345 plus 3, and then divided by 2. Okay, use calculator, we get 3.923. So to find the area of this triangle VRP, we just take s square root of the s, which is 3.923, times with the s, 3.923 minus a, which is 2.5, 3.923 minus b, which is 2.345, and then 3.923 minus c, which is 3. Okay, so with this, just press into press the value using calculator, then we get our final answer, 2.85 square meter. That's it. Thank you, everyone. So should you have any question, you can just leave your message at the comment area. I'll try to answer you. Okay, thank you.